Ports are the lifelines of our economies, moving 80% of global trade. But they are also hotspots for emissions, waste, and habitat destruction, while facing climate risks and other threats. The challenge is urgent, but it's also an opportunity to transform ports into hubs of innovation, efficiency, and resilience. Today, we're joined by experts who will inspire us with practical strategies and success stories on shaping green and resilient ports that cut emissions, improve air quality, and drive sustainable, future-ready growth across Southeast Asia. The webinar begins shortly. Please stay tuned.
Good afternoon, everybody. Thank you so much for joining us today. We're really pleased to join you live from the ADB headquarters in Manila today. So it's fantastic to be out here and delivering this webinar, which is our 7th webinar in this series. Ports sit at the centre of global trade and play a critical role in keeping economies, industries and communities connected. But increasingly, ports are also at the centre of another major transition, the move towards a lower carbon and more energy efficient operation. Globally, ports face both significant challenges and significant opportunities in reducing carbon emissions. As key nodes within the maritime supply chain, ports contribute substantially to energy consumption and greenhouse gas emissions, not only through the vessels that call at them, but also through the port operations themselves. Emissions from cargo handling activities, transport movements, landside operations, and supporting infrastructure all form part of the broader emissions profile. At the same time, vessels at berth can represent a significant source of emissions, and so therefore it's important that when we think about emissions associated with ports, we're thinking about this from a whole of system perspective. We are seeing a rapid development in areas such as alternative fuels, bunkering infrastructure, shore power, and wider transition planning. These changes present both challenges and opportunities for ports as they consider how to remain competitive, resilient, and fit for the future. Importantly, the opportunity extends beyond environmental outcomes alone. Energy efficiency measures, clean technologies, and renewable energy integration can reduce operating costs, strengthen resilience, and create broader economic opportunities. But achieving that transition requires collaboration across port authorities, shipping companies, government, industry, and financing partners. So, with that context in mind, today's webinar will focus on 4 key themes: future fuels and bunkering, shore power, energy infrastructure and transition readiness, and clean energy logistics and industrial capability. This webinar is the 7th in a series of webinars that aims to spotlight what leading ports around the world are doing to address some of the challenges and explore how their approaches can be adapted across Southeast Asia. This webinar is organised by the ASEAN Catalytic Green Finance Facility, which is managed by the Green Finance Hub, ADB South Asia Regional Department. It is hosted by ADB's Southeast Asia Development Solutions Platform. We have a fantastic group of speakers joining us today, and I'm really looking forward to the discussion and insights to come. We do have Wayne Mabbott, who is Senior Management of Terminals and Logistics at the Port of Newcastle, where he leads port logistics, coordination and operational efficiency across one of Australia's largest ports. Catherine Blaine is the Acting Group Executive of Assets and Infrastructure and Development and Chief Risk Officer at the Port Authority of New South Wales. She leads the planning and delivery of major port infrastructure across New South Wales, overseeing complex capital works and asset programs in live operating environments. Joining Catherine, we have Fauzan Zulkifli, who is a Senior Project Manager focused on shore power, leading the delivery of the Bay's Shore Power project, and he is also chair of the PIANC Marcom Working Group 248, which is focused on shore power guidelines and the Australian standards for shore power. And finally, we have Mike. Mike is a translator between technical and commercial languages, turning good ideas into investable projects and ventures. Mike is focused on some clients to realize the value generated by connecting traditional, technical and commercial silos. So without further ado, I would like to invite our first speaker to join us today. Catherine, if I could invite yourself to the screen, if you would like to share your presentation and join us, I'll hand the reins over to yourself and Fauzan. Thank you.
Great. Thanks, Jackie, and hello to everyone online. I'll just share my presentation. Okay, so thanks for tuning in, everybody, and we want to tell you a little bit about our little shore power project here in Sydney, Australia. So, image of where we are, give you a bit of context. So that photo there is of our White Bay Cruise Terminal here in Sydney. And the project is to deliver Australia's first shore power cruise ship connection at our terminal there. And as you can see in capital bold letters or big bold letters, first in the Southern Hemisphere for a cruise terminal. So we're obviously very proud of our project. The White Bay Cruise Terminal welcomes cruise ships to Sydney, and it's situated right in the middle of the city. So you can see the harbour bridge in the background there. You can also see just up behind our cruise terminal, we have a residential community that lives there. And one of the key drivers to why we're putting the shore power connection in. But also there's many benefits to shore power, which I'll run through in a minute. This project's going to cost us around $60 million in Australian dollars, so which is no small amount. And that is partially because we need to bring the power down into the port area to be able to power the shore power connection, which takes a lot of energy, obviously. But we'll talk through that a little bit more as we work through the how we're going to roll it out. So in terms of benefits, obviously there's a global benefit in installing shore power, reducing greenhouse gas emissions, and the ships are able to plug in to renewable energy while they're berthed alongside. They're able to turn off their diesel engines and saving all of those emissions into the atmosphere. So in a global sense, that's emissions reduction, which we've seen obviously come into the maritime space in a big way in the last 10 or so years. And there's obligations around shipping lines to reduce their greenhouse gases. So shore power is just one of the ways that they can make a big impact in that space. Obviously, from a local perspective, being able to turn off the diesel engines while the ships are in port lowers the noise emissions while the ships are alongside and the air emissions, which keeps our neighbours there right next to our cruise terminal happy. So they're looking very forward to us switching this facility on. And the aim is to switch it on at the end of December 2026. So at the end of this year, we should be operational at the port. So again, going through the justification for the work, obviously global decarbonisation and the local benefits to air and noise reduction. It also gives us a licence to operate in this area. So having a busy port in the middle of the city becomes increasingly difficult to justify as urban areas encroach on port areas, what were traditionally port areas. So we need to do our bit in terms of running a sustainable port. And shore power is just one of the key things that we're doing down there at White Bay to continue to operate sustainably. We're also providing leadership in the port section, in this port sector. Like I said, we're pleased to be an Australian first here. Shore power is not a new thing for the world. There's many shore power connections around the globe, but we're very pleased to be leading the way in Australia, and we've had a lot of input or involvement questions from other ports in Australia who are seeking to do the same thing. Now, just running through quickly how we're going to deliver our project. So we've split our project physically up into 3 works packages. So you can see there, works package 1 is bringing the power into the precinct. Works package 3 is an internal network of cables, trenching cables and connections that will take the power into the ship. And works package 2 is the specialist shore power equipment or the onshore power equipment that is required to convert the electricity to the correct voltage and to the correct frequency to be able to be taken on board by the ship. So talking through that a little more, works package 1, as I described earlier, this is probably it's a significant cost for the project. It probably makes up about 1/3 of that $60 million to deliver this project. And you can see that it's coming from this image down here. It's coming all the way from about 3 kilometres away from the nearest substation in a town called Roselle. So it's coming through the streets of this obviously heavy suburban area, coming down a main road and then into our port area all the way down here. So that work will be constructed by approved contractors, and that's due to commence in about a month's time. And it'll take the best part of a good 3 or 4 months to get that cable down into the port. Now, works package, I'm going to actually skip to 3 first. So internally, what we've been doing for the last several months is building the internal network of conduits, and we will run the cables in the next couple of months to take the power from where it enters the port and right up into the onshore power equipment location, which is here in the green bubble. So I'll show you what that looks like in a second. But from there, it then does all its magic and converts all of the electricity into the right voltage and the right frequency to be able to be taken on board by the ship. So we've got then another series of trenches and cables and conduits to take the power out to the ship and then along the wharf face. So you can see some images here that are actually of our construction that's happening on site. So you see the trenching that's happening, that's coming up and down this road here to lead to where we have the specialist equipment. Right here, we've got an image of a seawater cooling pit. So we're putting a seawater pump in there to be able to cool the shore power equipment, because as it operates, it obviously generates power and heat. And so you need to cool that. And so we've got a seawater cooling arrangement. So we're taking the water from the ocean here and bringing it through to cool it. And that's actually a very sustainable way of cooling the shore power equipment as it operates. And you can see here a picture of the trenching that's going along the wharf, which is this area here. And that is an example of an area there that we finished. So this area here is to so that the cable can traverse up and down the wharf, and that we can, and I'll flick to the next slide, so that we can run this unit here, which is called the cable management system, runs up and down the wharf and uses the energy chain that's in that pit to actually position itself to the appropriate location to be able to connect into the ship once the ship is alongside. We have lots of different ships visiting our terminal at White Bay there, and so we've had to allow that flexibility along the wharf to be able to position the cables at the appropriate location for each ship. And there we have, again, images of our own site here that were taken just a few days ago. This is the shore power equipment coming together there. This was built by a company called PowerCon in Denmark and pre-commissioned overseas. It is 10 containers worth, 10 times 20-foot containers worth of equipment in there, and nicely arranged there in that stack there that you see. The platforms are going in so that we can access and maintain them, and we'll be building a shield or a screen around them to make them a little bit more architecturally pleasant. So not that we don't like looking at shipping containers, because we do. Now I've been through that one. And I'll just finish by just showing you an image of where shore power has been installed around the globe. So like I said, it's not a new thing around the globe. There's a lot of ports that have installed and are currently operating shore power. The EU has actually mandated shore power to be installed for all vessels, all commercial vessels, by 2030. So there's a lot of activity going on in the European area in terms of connecting shore power and having shore power installations. So companies like PowerCon are very busy at the moment trying to keep up with that demand. You can see there's 38 active connections around the world, including USA as well, all those locations that you can see they're highlighted. There's another 20 funded and 30 planned. So shore power is a big deal. And like I said, we're very pleased to be installing the first one in the Southern Hemisphere. And that's it. Okay.
Catherine, thank you so much for that insightful presentation. And I think it's really great to see how you've broken down those individual packages of work. And I think that'll be really valuable for our audience participants to see today. On that note, if participants do have any questions at all they do want to ask of our panelists, please do use the webinar Q&A function, where you'll be able to pop your questions down and register those, and we'll get to those at the end during our Q&A session. But whilst I'm talking about questions and answers, I might just throw one quickly to Fauzan, because I know that you've been doing some great work in and around the development of standards. So just in a few minutes, can you maybe provide an overview of your involvement in developing the global standards for shore power and the general process, and then maybe a bit of an update on the publication timeline so that people can be aware of when that's coming?
Thank you for that question, Jackie. I think this is quite relevant to all the participants here because the first thing before we actually went out and delivered this project in Sydney, what we've done is we engage and talk to all the ports around the world. Just trying to learn from their lessons learned on how to deliver the project and then utilize that to actually form our project. So what we're doing here with Standards Australia, IEC, IEEE, and ISO on the technical standard is building up similar kind of methodology. Lesson learned from the development of shore power that we've got right now. And we put together a technical solution or guidelines or standards based on different shore power applications. What we're focusing for the last 3 years is to update the shore power technical standards for cruise connection, but also putting together new technical standards for bulk, low voltage, and DC connections. Our aim as the international working group, as part of Joint Working Group 28, is to issue the revised technical standard for cruise shore power by the end of this year. In fact, we're meeting in the next few weeks to attend to all of the questions from all the national committees, and then we'll be using that to actually update the standards and issue them at the end of the year. On the second work front, I'm also working with Piang to develop the guidelines. So these are not the technical standards itself. However, it is the guideline A to Z on delivering shore power, all the way from putting together the business case, the commercial study or analysis on delivering the project, fundings, all the way to the actual project delivery, risk management, implementation, operationalization, as well as maintenance. The focus of these guidelines, again, is to build upon experience of all the ports around the world. And one of the sections is actually focusing on lesson learned and case studies from each of the ports based on their delivery. Because we believe that having this section is useful for everyone so that they know exactly who to reach out to, because each port has their own challenges. And no port is the same. However, you can actually build that knowledge by engaging the port and maritime industry. The aim for issuance of this international guidelines is around October, November this year. So we'll provide an update to everyone later on.
That's really exciting, and thank you so much for sharing that information. I think both those technical standards and those guidelines will be very useful. I can see that we're getting lots of great questions coming in on the Q&A. So Catherine and Fauzan, if you want to respond to those and type some responses back, feel free to, or we can save them for towards the end. We will get through those questions as we get through the session today. But thank you so much to you both for your contribution. We'll invite Wayne Mabbott from the Port of Newcastle to join us next. So Wayne, if you want to pop your camera on and join us on the screen and share your slides, I'll hand the reins over to you. Looking forward to it.
Thank you, Jackie. Good morning. My name is Wayne Mabbott. I'm from the Port of Newcastle. I'm the Senior Manager for Terminals and Logistics. One of my roles is to look at how we manage, well, many of my roles, but one of my roles is to manage the handling of cargo through all of our common user terminals in the port. We have general cargo terminals, we have bulk terminal, and we have what we are now having a multi-purpose terminal at Mayfield 4. And that's probably the subject of my presentation this morning, is to give you an overview of what the challenges we have in the energy transition from a fossil fuel into renewables in New South Wales, and the implementation of all of the wind farms and battery storage facilities, and how that impacts the port and the logistics and port planning that we have to work through to get this is a fairly significant logistical challenge. So having said that, so the New South Wales government, through Energy Co, private investment, is undertaking the transformation of the state's electrical power supply system from fossil fuel reliance to renewable energy. That, as I said, a lot of wind farms are in planning, and we are currently bringing quite a few batteries at the present time. So renewable energy zones are being developed in New South Wales to enable this transition, with 3 geographical locations in the Newcastle catchment region. So the main one we're focusing on at the moment is the Central West Arana res, which is out around the region of Dubbo, Goulgong, Mudgee, Wellington, where a number of farms are being developed out there, and transition hubs are currently being constructed. So we see that as fairly, obviously it's within our catchment, and it's fairly within reasonably close proximity to the Port of Newcastle. So the port is at the forefront of this change as the principal port of entry for import shipments of renewable components, which in majority of are manufactured offshore. Places like China and Vietnam are the main producers, and to a lesser extent in Europe. And these projects require the import, storage and transport of large wind turbines and battery components. Energy Co is developing, to assist with this, the Newcastle Logistics Precinct on 5 hectares adjacent to the port for storage and distribution of turbine and battery energy storage system components. And the port's in collaboration with Transport for New South Wales for the port to res OSOM movement, which oversize over mass movements, which is the category of these cargo going out, and the capacity planning to enable that. So that's a bit of blur, but realistically, the reason behind this, the challenge that we face, is that we've done Port of Newcastle handled a significant number of these projects over the last decade, and generally they've been quite controlled projects with a shipment a month of the components, giving us the ability to store them in the adjacent land to our berth, and then control the feed of them out to the res as required. This most recent project that we have just undertaken was the Ungala project, 69 turbines in total. That's 69 turbines with 13 pieces to each turbine. These blades on the current ones are 85 meters. They're growing every year, the turbines. The blade length, for a start, is, when we did our first project 10 years ago, was 65 meters. They're now up to 85 meters. And it creates significant challenges from the transport and logistics to getting them from the port to the res. We've got approximately 1.5 hectares of available storage adjacent to our berth, which gives us the ability to store these components within that area and the ability to transport them at a more controlled rate to the res. We have capacity for 69 turbines. I know that because we got the 69 turbines of this project in that area as we speak. Most of these projects at some stage have issues with the construction or delays in their overall development, and that creates issues at the port side. Energy Co, this New South Wales government has invested 115 million into the Newcastle Logistics Precinct, which will be adjacent to the storage area at Port of Newcastle and in proximity to our berth. And that's scheduled for construction in 27-28, hopefully to be finished at the completion of 2028. In the meantime, we will have to utilise our own area, or as much as we possibly can, to be able to handle the volumes that are coming in in 27-28. There's a high number of these projects that are all in varying stages of planning and development within the res. Some are in the concept stages, some are in consultation, some are with planning, and some are actually being developed. So we expect the current project that we just completed for Ungala, it's in the construction phase now, but the next one we anticipate will be in late 27. This project we just completed, as I said, at 69 turbines. The next one that we think maybe Spices Creek, which is 117 turbines. Following that, we're looking at another one called Liverpool Range, which is 149 turbines. And then movements are specialised. They're all specialised road transport, and they're coordinated through the transport companies and the Transport for New South Wales. That being another one of the key challenges in the actual movements of these components and the size that they are, getting them out to the res and the restrictions that we have in movement. At present time, we work on around about 3 to 4 movements a day, which is all of these movements need police escort. They need pilot vehicles to travel with them. They're extremely long lengths, so 85 metres of blade plus the prime mover, etc., turns into about 100 metres of truck. Specialist vehicles to cart these things and specialist drivers to be able to move them. So, and there's a picture of a ship, because everyone likes a picture of a ship with some blades on the deck. That ship, I think, has 33 odd blades, all stacked in those nice little frames, and we discharge them one at a time onto a truck and run them out into our storage area. Takes about 5 days for one of those vessels to discharge at our berth. And as I said, as we get into the further development, that will increase the utilization of our berth. Currently, one a month is not a huge impact. We do other cargoes over the berth, ammonium nitrate, steel, containers to a lesser extent, but all of those are impacted when you have multiple vessels there. As these projects continue, we see that will impact the congestion on the berth as well. So the challenge for us, as I went through a little bit there, but the projects generally have challenges throughout their development timeframes, causing storage potential congestion at port. So that project that just finished, for example, I'm not giving any commercial in confidence, but the project itself went the development was behind, so they basically did not have any capability to store on site. And therefore, the whole project, the 69 turbines, 14 vessels, over 14 months, basically landed in Newcastle. We had to store all of that into our storage area. And as I said before, I know what my capacity is now because we didn't have another room for another turbine in that area. Renewable energy zones and sites, they're located, as I said before, Dubbo, Wellington at the present time, that in the CWA res. And then further out into the New England res, as time goes on, the distance, somewhere around 500k to get out there now. It's a long way. When you're transporting something that, potentially can only move at 30 kilometres an hour at times, there are challenges in getting those out in a controlled period of time. Also have oversized over mass movements are only allowable within curfew hours outside of the port. So we have a curfew from 9 p.m. at night the curfew only allows for transport from 9 p.m. at night till 5 a.m. in the morning. And there are also various curfew periods along the route to some of these places as well. Bearing in mind you're going through residential areas, you're going over old infrastructure like bridges, regional roads, built up areas in small towns that are basically you're really just passing through. So there's a lot of issues, no overtaking lanes and things like that for these. So the government is working closely on those upgrades to the roads to accommodate this. And we're in consult. The other key point in that is consultation throughout this process. One of the challenges we've found is that a lot of these projects basically nominate the Port of Newcastle as their entry port when they lodge their DAs, but they haven't really consulted with the Port of Newcastle about how that's going to be managed. So we've had conversations with the regulators so that we can get them on board when someone does lodge an application to give us as much information and consultation with Port of Newcastle as much as they can so that we can then plan for those things. We've had issues where we haven't heard of projects and they're on their way or being shipped, and that's very hard for us to manage. And then we have the potential going forward when we get into late 27, 28, I think 2028 will be the main, when it starts to really ramp up. And then we're looking, if we start to get multiple competing projects overlapping, So far, we've had the luxury of having one project at a time. So the storage area can be managed by a single operator, and maximising your capacity, putting blades with blades, towers with towers, etc. But when we start to look at how that would work with a multiple project or multiple parties, there are numerous challenges within that, and how we would manage two operators in the same point at any given time. But what comes with challenge is opportunity. So what are we doing? We're collaborating with Transport for New South Wales and Energy Co on the Port to Res ASOM capacity planning. One of the key issues here is it's not so much about getting them in, it's also getting them out. It's like any sort of storage capacity, you need to turn over as much as you possibly can. So every time you bring one in, you need to bring one out. And that's what we're working with Transport for New South Wales and Co and how we can manage that in a better way, because when we start to get the number of projects that are on the books, we will start to get a continuous movement out into these res areas, and that's going to be a challenge on how many we can actually move a night. Like I said before, we work on about 3 or 4 at the present time to get to the numbers that we're talking about in 28, 29. We're talking moving that up to a more significant number, which is going to be a challenge, because there's only so many slots to get these things out. We're developing additional hard stand to handle the increased import. So we've got a terminal that we have limited space on. We're going off to our business to get some more approvals to develop that further. We've done a fairly significant work in our own storage area that we have currently, so that we can store both these these towers at sections and battery components. And our plan is to get us through for the next few years while the Newcastle Logistics Precinct is being developed and getting to finalisation. And we're assisting Energy Co and their consultants in the design and access requirements, so that we can have a smooth access into their facility when it's operational. We're also coordinating with the stakeholders on systems for traffic management. As I said before, the issue with getting them in and out, and then obviously working with the stakeholders to make sure that they can get these things in and out as well. And we're learning from others, getting advice from other parties on how they managed their facilities. Getting close to wrapping up for you, but New South Wales government's invested quite significantly in this port to res to give us upgrades in roads so that we can get these things out to the res. They've put 128 million across 19 intersections and upgrades of the roads between the port and the Central West Orana, and they've just announced an additional 183 million to fund that as well. And that's about it from me, guys. Thank you very much. And if you want to, there's another lovely picture of what 69 turbines looks like in our storage area. And that's about it.
Thank you so much. It's great to see the renewable sector growing through the Port of Newcastle, and it's actually amazing to see 69 turbines on that laydown area outside the back of Mayfield 4. So thank you so much for sharing your insights with us. If there are any questions for Wayne, please don't hesitate to pop those to our Q&A session. But yeah, appreciate your contribution there, Wayne, and if you're happy to stay online for a little bit longer, just to see if any of those questions come through, that would be fantastic. We'll do some Q&A at the end. So next, I'd like to invite Mike Strawn up to join us. So Mike, if you want to join us and share your slides, I'll hand over to you to round out the session of presentations. Thank you very much.
So yes, good afternoon, everybody. I'm going to just touch base a little on low carbon liquid fuels. We've heard some really interesting things around shore power, but ultimately vessels transiting long distances, will need alternatives to their current heavy fuel oil approach. So this gets to go. So I'll just run through a bit of background and context to the whole sector. That's quite Australian focused, but I think it's regionally applicable. I'll skip through some decarbonisation pathways, basically what type of fuel do we think is credible, and then touch very quickly on some case studies. I've got quite a lot of information in here, but I'm very conscious of time. So if people want specific questions around case studies in particular, then perhaps drop it in the chat and we'll address it towards the end. So many of you will be aware that the European Union in particular is really driving decarbonisation through its Fuel EU and EU maritime programme. So fundamentally, it's a carbon tax which is calculated based on a well to wake approach, where there's a carbon penalty that applies to non-certified fuels that covers half of the journey in, half of the journey out of the EU. And as you can see in the middle of the screen there, there's a penalty of €670 a tonne CO2 equivalent for non-compliance. There is also mechanisms within Fuel EU to identify and ensure that feedstocks that are used for low carbon fuels are not competing with food production. So you'll see this RFNBO. That's a category of feedstock, which means you can't be competing with food. So in terms of demand between the transport sector, Fuel EU, which is the maritime sector, and then Refuel EU, which is the aviation sector, there is a very, very large increase in demand anticipated for these low carbon fuels. And thanks to Argus for these slides, for these images. So the International Maritime Organization, which is the maritime body of the UN, has broadly implemented the EU guidelines and is going to implement a very similar well-to-wake approach through MARPOL, so the anti-pollution regulations administered by the IMO. This process, the adoption rather of the IMO regulations, has paused a little at the moment, with some lack of alignment from earlier workshops this year. They are, however, reconvening the particular working group that's going to implement this work later this year. So there is general optimism, I believe, that this will get more traction towards the end of 2026. It's also worth noting that many ports have their own decarbonisation targets, not just ship lines. So I've been working with the Port of Brisbane, for example, to implement a trial of renewable diesel on its dredger, which in its own right accounts for nearly 90% of the port's Scope 1 emissions. So as we're all aware, current conflicts in the Middle East have also refocused attention on fuel reserves and sovereign capability. So over 50% of Australia's liquid fuel use is in diesel, and over the last 25 years, 15 years, increasing numbers of closure of refineries, to the point where Australia now imports about 80% of its own refined product from many of your ports on the line. And so there is a real refocus on sovereign capability, storage volumes, as we go through. And I think we shouldn't ignore that kind of sovereign risk element to this when we look at decarbonisation. I might skip this a little bit. There are some policies both at Australian government and state government levels, but in the interest of time, I'll skip these. But these slides will be available later. So what can we do about it? I've been putting my mind to this again with the Port of Brisbane and others, and I think we can kind of delineate three real timelines of a now. What's available, new, what's emerging, probably technically feasible now, but not quite commercially feasible yet, but should be in the next 5 to 10 years, and then a future scenario where we're at kind of laboratory bench or demonstration scale. So, there are drop-in fuels available now that you could use in your landside or indeed your marine side fleet: biodiesel, renewable diesel, and batteries. We've heard about shore power, but there are there are also increasing uses of electrical, both landside equipment and vessels. In that emerging space, I think we will almost certainly see much more biodiesel and renewable diesel. We're seeing more and more hybrids being introduced, so diesel-electric hybrids in both landside and marine side. And we're also seeing lots of bio-LNG orders. We're also seeing ship lines placing orders for methanol ready vessels, so they're not necessarily running them on methanol at this point, but the engines will be ready to run on methanol. And then in the future, I think we'll see more and more space for electrics as battery technology increases. I think we'll see more hydrogen fuel cells in particular for those very long duty landside equipments, and again potentially broad update of both methanol and ammonia for long distance shipping operations. Ammonia obviously bringing its own challenges in terms of handling. So here's a bit of an eyesight test for some of you, but I thought it's useful to just give a really brief overview of actually how you make these low carbon fuels. So again, I'm not going to go through this, but bring out your chemistry textbooks and you can investigate all these various technologies to produce these fuels, which are either used as a drop-in fuel, so that's the darker boxes along the bottom, or a blended fuel in the pale yellow boxes on the bottom. From a decarbonisation perspective, so how effective are these fuels at reducing carbon? They are very effective. So you can very easily get 90% plus carbon reduction, which is exceeding some of the EU and IMO targets. And as I said earlier on, lots of these technologies are technically viable now, so they are very high technology readiness level. Some of the ammonias and the e-fuels are not quite there yet, but commercially they are a long way apart from the current fuel crop. So whilst we talk about technology readiness, commercial readiness is still very, very challenging for many markets. Interesting dynamic with the current Gulf crisis, where we saw price of refined fuel in particular leap very significantly. Interestingly, renewable fuels feedstocks have also leapt, and that's in part due to the requirement for fertilizer to grow those, but also lots of people now investigating, and so we are feedstock constrained in the volume of the fuel that we can produce. So again, good to see Wayne, Port of Newcastle on the line, but I think many ports have their own decarbonisation targets, as I mentioned, and we shouldn't forget the alignment between these strategies and the various studies into green shipping corridors that are underway at the moment. Just touching on ship lines, I think Maersk is probably the most advanced in this space, very focused on methanol ready ships, including to the point where they've worked out a bunkering solution in Japan. Maersk is also exploring ammonia, but as I said earlier on, I think there are some other challenges with ammonia from an environmental and toxicity perspective. CMA, CGA they've really focused on bio-LNG in the short term, and CSL have actually been operating some of their vessels on the Great Lakes on biodiesel. Interesting to note that they typically only operate their biodiesel fleet during the summer because biodiesel is impacted by extreme cold and moisture. Just touch on Svitzer. So again, they've been looking at both methanol and electric tugs, and interestingly have just signed an MOU with the Port of Melbourne to deploy new electric tugs into the port, including shore power. Won't touch on dredging contractors, but again, logistics companies, Landside, Toll Group, DP Worlds, there's many trials and operational activities underway using a range of electric and renewable diesel equipment. And I guess just touching very briefly on the supply side. So how available is this material? I mean, as I said, renewable diesel is very available. Much of it comes out of Singapore and China. Neste in Singapore in particular dominates supply to the Australian market currently. Typically supplied in an isotainer, so 22,000 litres or thereabouts at a time, which does make it quite expensive. There are a number of growing project developers down here who are looking at dedicated low carbon fuel projects. And again in Australia there are a couple of biodiesel manufacturers, but again many more in Southeast Asia. So a very quick run through the low carbon fuel market. It's moving rapidly, driven by those international regulations and current crises. I did note the challenges that the IMO is having, particularly around the US administration not being supportive of climate policy, but with an expectation that the alignment between those parties will get that together. There's many local international organisations remain committed, and there's lots of trials happening, but commerciality remains a real challenge. So thank you.
Mike, thank you so much for your presentation. There was a lot of information there and it was really insightful, and I particularly enjoyed your chemical breakdown of all the different feedstocks going in to those different fuels. So thank you for sharing that. I know that there was a few screenshots being taken this end of that particular slide, so it definitely generated interest, so thank you for that. We have got a few questions on the Q&A, so I'd like to invite all of our speakers to join us back. Mike, you can keep your camera on. Join us back on the screen. Unfortunately, Wayne Mabbott has had to leave the call. He had another commitment that he had to get to, so unfortunately we won't be able to answer the questions targeted to Wayne, but we've certainly got Mike and Catherine and Fauzan in the room, so we'll crack on with some of those questions there. So I might kind of go to the top of the list with our very first, in fact it's not our very first question, so just bear with me, I'm just going through the Wayne ones. So what's your take on non-conventional fuels like SMR power reactors? Mike, what's your thoughts in and around that?
Start with the easy ones here.
Sorry.
I mean, we collectively have been running nuclear powered vessels around the globe since the late 1970s. My personal view is, why would you not? Low carbon, obviously costly, but the overall carbon reduction, lack of fueling, and the safety case, I think has been proven for SMRs, for marine work. I mean, I think there is a public perception risk issue that absolutely is probably the primary barrier.
Thanks, Mike, and hopefully that answered that question that came through there. And sorry to start you off with a relatively tough one. For the Port Authority team, Port Authority New South Wales, we've got a question coming in from Richard. So this is quite a long one, so give me a minute while I read it out to you. But in the Netherlands, the use of electricity from OPS may be subject to commercial electricity rates and VAT, which is the equivalent of tax, whereas gas oil is bunkered without taxation. Additionally, some large energy consumers get better electricity rates, way better than commercial rates. So it would be beneficial if some port industries would actually invest in OPS and offer these services themselves to improve the business case. Is this also an issue and potential business model in other countries outside EU? So is this something that has come up across the work that you've been doing for your project?
Yeah, so we sourcing of the renewable electricity for us has been a big consideration, in terms of that we need to provide, I suppose, a tariff or a cost to the cruise lines that is hopefully less than what they pay for diesel fuel. In terms of the use in buying kind of big quantities and buying in bulk, we have tapped into or trying to tap into a larger state government contract, because we have other kind of state government cousins, let's say, that use a lot of electricity and far more than the port uses. So we've tapped into their contract agreements for renewable electricity and then been able to secure a lower tariff with that kind of bulk buy. It also, with shore power, the other problem with purchasing electricity is that shore power is a kind of a spike. So a cruise ship plugs in and then uses a lot of electricity and then goes away and uses nothing. And the electricity providers or the energy providers do not like that. So that's not a good thing. It tends to drive tariffs right up. And so by piggybacking on another state government contract, we've been able to kind of smooth out that electricity demand and then protecting our cruise customers from that kind of spike and that large tariff. So in terms of the other part of the question in jumping on board with production of renewable energy, it's not quite practical for us and the level, I suppose, and the scale of what we're doing. And I suppose in terms of renewable energy in Australia, it's another topic in itself in getting that secured and built. So but that's the way that we're trying to kind of minimise the cost of the renewable energy by hopping on board with our cousins.
I love the use of cousins, and I think that's just a really great demonstration of kind of collaboration and partnerships and identifying synergies with where there's a kind of co-benefit there of sharing that approach. So thanks so much for that versed response there, Catherine. Appreciate that. Mike, back to you. I've got a question around the reliability of feedstock. So can you just give us a bit of a insight into that, thinking about weather events, fertilizer prices, etc. I know you touched on it lightly, but it'd be great to get some more colour if that's okay.
Sure, yeah. And again, I think, the renewable fuels of non-biological origin, which is the EU test, does put quite a significant limit on what is available as a feedstock for accredited fuels. And so, typically they would be either a waste crop, so that's things like forestry biomass, so residual timber, for example, from a sustainably sourced timber plantation, could be canola, could be there's a whole range of different energy crops, including sugarcane, ethanol, you name it. I think the core difference between, let's call it mineral diesel and renewable diesel or renewable fuels is there's a real difference between, so traditional oil and gas is capex very intensive, but then your opex is actually relatively small. That's completely flipped for renewable fuels. So you have very little capex in the scheme of things, but you've got to buy your feedstock. And so that feedstock is subject to natural market forces. So, if a major producer of that feedstock has a weather event, or we see a tripling of fertilizer price due to, a certain geopolitical event, then that obviously impacts almost immediately through the supply chain, which we don't see in fossil gas, in fossil diesels, fossil fuels. So I think it is a real challenge, and it's also aligned with, I guess, a relative immaturity of the market. The volume is relatively small at this point in time when compared with with legacy fuels, and so a shock results in a huge change in the price as opposed to a shock in the the traditional sector. Yes, it has an influence, but it's 5 or 10%, whereas this last recent event, the price of renewable diesel has doubled.
Quite significant. Thanks, Mike. I might stick with you. I've got another question, if you don't mind. So the IMO has a mandate for draft maritime conventions, which are then passed on for adoption into national legislation of member states. But what overarching authority has global jurisdiction for ports?
It's a great question. I don't think there is one. I mean, the IMO is the maritime organisation, it's the vessels. I don't believe there is a port. One and others on the line may well may well have a better view than I, but my understanding is there is no, same as airports, there's companies, or sorry, country specific policies, guidelines, requirements, but there's no overarching at an airport or port level that shall use 10% renewable fuels. But there is for the vessel and or the aircraft.
Which then kind of brings those kind of layers of international regulation, regional
Correct.
regulation, and kind of need for some degree of harmonisation, which I think is a challenge
Correct.
that most on this call and associated with the maritime sector and ports and shipping will be very, very much aware of. So yeah, no, great answer, Mike. I think we've got time maybe just for one more question. So I might throw this one to Catherine and Fauzan, and you can choose who you want to answer. But do you know of any smaller examples of shore power for vessels, so smaller scale kind of projects? Obviously, yours is a significant project. Have you come across any other smaller scale projects during your experiences and knowledge sharing adventures?
Yeah, for sure.
Answer that one?
Yeah, do you mean smaller as in smaller for cruise vessels or just any type of smaller vessels?
I think if we're thinking kind of smaller, developing ports who might not have the same kind of scale of infrastructure, maybe something that could be tangible for that.
Yeah, for sure. I mean, when we talk about our project, we talk about cruise vessels. So we talk about the biggest energy user, the biggest. So, our little project is on the kind of large end of the scale. And then there are projects that are many other ports that are doing multiple cruise ships. But when we talk about smaller vessels in terms of ferries and even container vessels, and bulk vessels use less energy. And some of the smaller ones that we've seen are around that kind of the ferry size or the carrier size, where it is a lot, I suppose, easier. It's a bit, and it's easier and less costly to put in shore power connections around those vessels. So obviously they use a lot less power and a lot less fuel, and so it becomes, the infrastructure becomes kind of less onerous to install. The cost becomes less, the fuel or the electricity supply is less, and so it's a lot more attainable to put in your smaller connections for those smaller vessels. And what was I going to say about it? So the ferry connection, I'm just thinking about what the one we saw in Rotterdam, that the Roro connection. So like I said, there's plenty of examples around the world where, and even in Australia actually, where they have a shore power for a ferry connection.
And then a lot of the examples for smaller scale shore power projects are based in Scandinavian countries. So smaller ports, they actually utilize a lot of low voltage shore power connections. And that is something that we are developing as part of the international standards as well. We're seeing more and more application with regard to low voltage shore connection. So either ferries or just small application of inland vessels. So that is applicable within this case as well. But a lot of examples within Northern Europe or Scandinavian countries here. Yep.
That's great. Thank you so much for sharing those other examples, of which I know beyond your particular project, which is a fantastic project, but it really does sound like we're going to have to look forward to those guidelines coming out, Fauzan, and the technical standards. So as we wrap up, I would just like to say thank you so much to all of our speakers today. We really appreciate the expertise and the experience that you've brought to the table today and shared with our participants. There's a lot of value in there, and we're very grateful. We hope that you'll join us for our next webinar coming up in June. We're about halfway through the series now, so we've got a few more as we come up to the end of the year. But yeah, June is our next one, so we'll look forward to seeing you there. Thanks again to our speakers. Have a great weekend, and we'll talk to you soon.